SwayamPrabha. Digital India. Educated India.
Good morning, friends. Welcome back to this wonderful session. As you recall, we have completed courses on airplane performance, airplane stability and control, and also some insights on stability augmentation system. And as I told you, all these things are preparations for running a course on aircraft design. But before we go for a new course on aircraft design, I thought, let me take a short course, a 10 hours module, which will give you exposure on introduction to experiments in flight. Because you will appreciate whatever we do in classroom on blackboard or a green board, we need to know in practice, can we validate this? Are these correct? What are the issues when I try to do an experiment to validate whatever physical understanding we have got? So it is important, extremely important, that we conduct some experiments to see how good we are in understanding or developing the laws of physics. And once I talk about experiments, generally in our education system, there has been a lack in giving stress in experiments, although last few years we are all conscious and we are giving due weightage, but it takes time, it takes infrastructure. It's not so simple, especially when you want to do something with aircraft. You need a huge infrastructure. You need airplane, you need airstrip, you need licensed engineer, so many things, pilot. And fortunately, IIT Kanpur has that facility, and most of the engineering colleges who are running aerospace engineering, they put their effort to get a slot in IIT Kanpur to undergo this course. But then it is not possible to conduct these courses for all the colleges because there is a manpower limitation, time limitation, and there is a cost involved. That's why I thought maybe a 10 hours module, I will give a lecture on the introduction to experiments so that you know how to conduct the experiment, what experiments we conduct, how to get the value out of it. Once we are prepared for that, and if there are requests, I can request NPTEL to arrange a facility in terms of finance, in terms of other support, so that you can come here in a particular slot and jointly you can do this course on the experimental side. But this course is preliminary, meant for giving you an understanding what are the experiments and how important are they and how simply you should be able to do it, right? So let us come back to whatever we have learned so far. We have learned primarily some aspects of airplane performance. We have learned things on stability and control. And if you recall, when you talk about airplane performance, we were mostly focusing on cruise and few maneuvers. Of course, you know, climb was integral part of a cruise because once you want to go to an altitude, you have to climb. Initially, you have to go for a takeoff, then climb, cruise, then descent, landing, etc. And if I look at cruise, I know in cruise the thrust equal to drag. So if you see here, there are 4 forces who are responsible to define a cruise. Of course, we are assuming that when I am talking about cruise, I am assuming the aircraft is statically and dynamically stable, right? Now, if I look for all these 4 forces, if I want to do experiment, then as far as thrust is concerned, this is coming from engine. So if you want to do some measurement, how much thrust or how much power the engine is developing, that will be primarily governed by the environmental condition and also how the engine has been made. What is the thermodynamics associated with the engine? Therefore, you will find when you want to measure thrust or power, let me say power for a propeller, an IC engine backup, typically our aircraft here, Cessna 206, Sinus, etc. There, if you want to measure what is the power being delivered, we call it power available at any altitude, this will be function of RPM and manifold pressure. And of course, you will find outside air temperature also will decide. RPM you know, manifold pressure loosely you can think this is the pressure at which fuel air mixture is happening, and outside air temperature, the outside air ambient temperature. Once we know these things, suppose I am flying and through a dial gauge, RPM gauge, I note down what is the RPM, through a manifold pressure gauge, I know what is the manifold pressure, and I measure the outside air temperature. Then through engine chart, engine characteristics, which is supplied by the manufacturer, I can easily find out how much power under that condition it was delivering. Right? So it's not a big deal, but the thrust is specifically for a jet engine. Mostly our experiments are with a propeller-driven IC engine. Right? So we talk more about power. Now, as far as weight is concerned, if I now talk about weight, weight will be weight, empty weight, then fuel, then passenger. This is the primary component. When I talk about weight of the aircraft, it is empty weight, fuel weight, and the passenger weight. Why weight is important, you could see here. After all, when I am cruising at an altitude, if the weight is more, I need lift more, right? Lift more means either I achieve that lift by speed or angle of attack. So the performance will be largely governed by the weight of the airplane. So if your weight measurement is not correct, then your performance estimation will not be correct. So we need to know how to measure the weight. This is one. And then if you see this aerodynamic force, drag and lift, for drag, you know that drag I can write as half rho v square s CD naught plus k CL square, right? And you know also this, that CD naught plus k CL square, this we call drag polar. So if I want to extract the drag polar of the airplane through experiment, flight experiment, what essentially means through experiment, can I estimate CD naught and K? If I can estimate CD naught and K through experiment, that means I am extracting the drag polar of the airplane, because I am assuming that this airplane will follow a parabolic type drag polar equations. That's very important, right? Okay. So one experiment will be, how do I estimate CD naught and K, or in turn I can say how can I estimate drag polar of the airplane. So what are the things here in drag polar? If I want to see CD naught and K, if you see here half rho V square S, what is rho? Rho is the air density. Rho is air density. How will I estimate or how will I calculate this density of air when it's flying at some altitude? Very important thing, we'll be following the gas law, rho RT, and this T we'll measure using a outside air temperature indicator. Right? This T will be taking help of outside air temperature indicator, which is in the cockpit. And what about pressure? Pressure, this altimeter is based on the static pressure under standard atmosphere assumption. So from these two values, I will be able to get the density as rho equal to P by RT. So I am just briefing this so that you know what are the measurements required. So in a nutshell, what we see here before we really do the analysis or discuss the procedure, we know very well that I need to know how to measure the weight of the airplane. I need to know how to measure outside air temperature, speed, altitude, so that I can find out the drag polar. Okay. With this understanding, let us first understand how to measure weight of an airplane. Weight is extremely simple. We have 3 vernier setup, and I will be showing you a demo also. It is like this is the main scale of the vernier, and this is the finer scale. Similarly here, similarly here. Right? And what happens? We drag the airplane and put the nose wheel on this balance, the left landing gear on this balance, LG is left landing gear, and right landing gear on this balance. This is the nose landing gear here. This is the left landing gear, this is the right landing gear, and nose landing gear. So by using this vernier scale, you can balance it and note down what is the reaction. Let's say R1, a reaction here is R2, a reaction here is R3. Okay. So then what is the weight of the airplane? Then weight of the airplane will be R1 plus R2 plus R3. As simple as that. So when you are going for an experiment with, let's say, 4 students in the same flight, so all the 4 students should sit inside the airplane, and the whole airplane will be dragged so that its nose landing gear, left landing gear, and right landing gear are on the balances. Using the vernier scale, we measure R1, R2, R3, and simply find the total, and we say this is the W takeoff. Okay, this is W takeoff. But now the question comes, now from here, after the measurement, we take it to a taxi runway, do the warm up, and go for a takeoff. And we climb, 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 and then go for a cruise. So when I am cruising, that time the weight is not the same weight what I have taken as W takeoff. But for cruise experiment, I need the weight when it is cruising, at which it is cruising. So what do? We carry a stopwatch. Carry a stopwatch. Right? And start ticking the time from here till it goes to the cruise altitude. And let's say that time is T, and you know what is the fuel consumption of the airplane. Fuel consumption, let's say that is m dot. So you simply, during calculation, you multiply m dot into T, so that much fuel has been consumed. So whatever W takeoff you have measured, you minus m dot into T, so that becomes your W cruise with which you are doing experiment. But yes, somebody may ask, sir, during cruise also some fuel is being consumed, so this will not be exactly correct. So for that, what we do, once you are starting the cruise here and ending here, you again take that time and take the average value. Another approach is you go for a W takeoff, come, land, take the weight again and take the average weight. So these things are within our jurisdiction, and we should be aware how much error we are going to commit in this whole process. Okay? Now, so once we know weight, you will ask a question, sir, it is CG is also important when you will be doing the stability experiment, because for stability it is not the weight, it is the location of center of gravity vis-a-vis the neutral point is important. As we know, for a statically and dynamically stable airplane, the neutral point should be behind center of gravity of the airplane, at least minimum this is, right. Strictly it is a static stability condition. So let us say how to find CG. Suppose this is your R1 and this landing gear it is R2 and this landing gear it is R3. It's very simple. You take any reference line and you know always the distance A, this distance B and this distance C, and this is the distance you get from the aircraft manual, that is separation between all the nose and left right landing gear. So if I know this, if it is a reference, if I know R1, R2, R3, I can easily find out center of gravity along x-axis as if this is your x1, if this is your x2, and this distance is x3, then you know center of gravity will be R1 x1 plus R2 x2 plus R3 x3 by R1 plus R2 plus R3. As simple as that. So to find the weight and center of gravity, what is the procedure? Take the airplane to the balance, note down the reactions R1, R2, R3, total it up to get the weight. So weight will be R1 plus R2 plus R3, and if you want to find center of gravity, I will simply use this equation. As simple as that. So that is the first experiment you will be doing, the weighment of the aircraft. It is extremely important, that is why we always start with this procedure, how to find the weight of an airplane. Okay. Now we are coming to the cruise experiment. We call it cruise experiment. Let us see what is the meaning of that and how do we do that.